Hello everyone, this is Jency Monica and we are back with another project that is design of SCADA for real-time applications using LabVIEW and Microcontroller. So let me give you a brief introduction about our project. SCADA, that is Supervisory Control and Data Acquisition, is a process control system that enables a site operator to monitor and control processes that are distributed among various remote sites. A properly designed SCADA system saves time and money by eliminating the need for service personnel to visit each site for inspection, data collection or logging or make adjustments. Supervisory control and data acquisition systems, that is SCADA, are computers, controllers, instruments, actuators, networks and interfaces that manage the control of automated industrial processes and allow the analysis of those systems through data collection. They are used in all types of industries, from electrical distribution systems to food processing to facility security alarms, and this project is about the work done in implementing a greenhouse parameters control system. It monitors the physical parameters of a greenhouse system such as temperature, humidity, soil moisture, and intensity of light on a real-time basis. And this paper presents that data acquisition system by PIC16 controller with LabVIEW interface that is capable to monitor and measure few of the most important parameters. Now coming to the motivation of this project, for monitoring and assessing the performance by acquiring and controlling the physical parameters such as temperature, humidity, soil moisture, and intensity of light of a greenhouse system on a real-time basis. This is done using software like LabVIEW along with low-cost microcontroller-based data acquisition hardware as DAC card. This real-time monitoring of physical parameters can be acquired and saved into the database files like MS Excel or other format and can be communicated with other PCs as well. Now, coming to the literature survey of this project. The first paper we have referred to is International Journal of Innovative Research in Advanced Engineering. The detection methodology here is, this paper presents a data acquisition system by PIC16 controller with LabVIEW interface that is capable to monitor, measure few of the most important parameters. The advantages would be, an embedded system is designed based on measuring of parameters like humidity, temperature, soil moisture, and light intensity. And the disadvantage would be, SCADA system is complex in terms of hardware units and dependent modules as the system is complex. It requires skilled operators, programmers to maintain SCADA system. Now, the next paper we have referred to would be Data Logging and Supervisory Control of Process using LabVIEW. The detection methodology here is, this paper gives an overview of data acquisition, data logging, and supervisory control system of a plant consisting of multiple boilers. Data acquisition, data logging, and supervisory control are the basic building blocks of plant automation. The advantages would be, it simulates the process and the generated data are logged in to the database with proper indication about the status of the process variable. And the disadvantage is, data loggers typically have slower sample rates and there is a limitation on the customization of the themes of components.
Continuing a literature survey for designing a SCADA for a real-time application using microcontroller and a LabVIEW. The next paper is a remote monitoring multi-point temperature system based on a SMT16030 and data socket technology. This is the International Congress on Image and Signal Processing paper, published in the year 2012. Detection methodology is for a remote monitoring of a multi-point temperature in the low temperature field. A remote temperature monitor system without the slave computer is realized using a local area network, that is LAN, which is based on a LabVIEW. The system used a client-server network mode. Advantages of this type of paper is, this system has many advantages of building a simply, fast and high accuracy, etc. Disadvantages are, data socket technology is used to transmit temperature information to the client. and the temperatures are extracted on the client. Because of using this technology, cost of this project is high. The cost is high and not that efficient. The next paper is Dr. Aditya Goel and Ravi Shankar Mishra published this one, Remote Data Acquisition Using Wireless SCADA System, Journal of Engineering. Detection methodology are the proposed implementation of the system solves the problem of continuous monitoring of a data acquisition system. The data acquisition system developed in a compact, low-cost 8-bit system. Advantages are like to get an array of data using remote data acquisition using wireless SCADA system. But the disadvantages is this is not that much accurate because SCADA is used here. Coming to the methodologies of designing this project is an embedded system is designed based on the measuring parameters like humidity, temperature, soil moisture, light intensity using a microcontroller named as PIC16FH77A, which are displayed. Those data are displayed using an LCD which is connected to the microcontroller through a RS-232 communicating with a LabVIEW. The graphical user interface is made in a LabVIEW software. Designing part consisting of a hardware and software implementation and interfacing protocol. Coming to the hardware design, this implementation of the system solves the problem of a continuously monitoring the data acquisition system. Here the sensors are used like a humidity sensor, temperature sensor and soil moisture sensor. These sensors are interfaced with the microcontroller. The data acquisition system is developed as a compact, low-cost 8-bit microcontroller. The system was designed to versatile and all operations are under software control. This will allow for a future expansion or modifications without the need for a major hardware changes. The system is connected to the computer through a RS-232 serial link to allow user communications and download the recorded data to the computer for subsequent analysis. Serial interface between the data acquisition system and the computer is implemented using MAX232 line driver or receiver, which used to convert TTL voltage required by the data acquisition system to the -12 volt to +12 volt needed by the computer for RS-232 communication. For the software descriptions, the software includes the reading of a various measurement from the sensor, converting analog to digital values and displaying those values on the LCD model and sending this data to the PC via serial port RS-232. Of the greenhouse parameter from the LabVIEW, the data logger is made in a LabVIEW which continuously updates the data in a database. Sensors used are temperature sensor, humidity sensor, soil moisture, light sensor. Implementation of a SCADA. This diagram is for compound configuration made in a LabVIEW software, and this is the LabVIEW we are acquiring humidity and the data logger.
Hello everyone, I am Tayama. Now I am explaining about the block diagram of the greenhouse controlling parameter by using SCADA system. We already know that the greenhouse parameters like temperature, light, soil moisture and humidity, we are controlling by using SCADA system. Whatever this embedded system is designed, the measuring of temperature, light, humidity and soil moisture by using this PIC16FH77A, whatever the parameter that is displayed is by using the LCD display, and these whatever the parameters result we are getting, that is sent to the LabVIEW, the PC. That LabVIEW will represent the graphical represent of the temperature, light and humidity, soil moisture results by using the RS-232. Then it is connected to the driver. It will get the results of temperature control relay and whatever the relay we are giving to the by using driver. Then next is the applications of the greenhouse parameters controlling by using a SCADA system, like electrical power system and operation control. And by using SCADA, we are whatever the power we have to generate and transmission and distribution. Then manufacturing industry or plant. The SCADA used really manufacturing industry and plants by controlling the raw materials and items. Then it is also used in telecom and IT based systems by using data lagging and radio frequency communication. Thank you.
Hi, hello everyone. This is Likita. So you already guys get to know what project we are doing and what technologies we applied in this project. So let us continue with the application. So for what purpose the SCADA is using. So the SCADA is using for water and sewage treatment plants and supply management. SCADA-based systems are used by state or municipal corporation to monitor, control, and regulate water capacities in reservoir. And it is also used for traffic controls. SCADA helps in regulation of traffic signals, control the traffic flow in railway system on road system, and the air traffic controls. And it also used in the lift and elevator controls. The SCADA can also be used for lift and elevator controls. So in this slide, it shows the expected result. So what type of result we are getting in this project? So as we are using the LabVIEW to implement a block diagram, in the LabVIEW we have the front panels. We are using the graph to represent the temperature, humidity, soil moisture and light intensity. So the front panel of monitoring and measurement of the greenhouse parameters, like I already said, temperature, humidity, soil moisture and light intensity is presented. So for security purpose, username and password is to be entered to monitor real-time data from the sensors. So the real-time data from different sensors are to be monitored on the individual chart. So appropriate set points are to be set for each sensor. So when there is a data from each sensor or from the set point, then appropriate LED is on, and at the same time there is a control circuit connected to the PIC16 either on or off depending upon the requirements. So these are all the references that we are refer for in our project. So this slide shows the link to the individual subject, where the subject link in our project. So first subject that we are used is virtual instrument using the LabVIEW. In this we are using the software LabVIEW. Using the software LabVIEW we are implement our block diagram in this project. The second is automatic process control and modeling techniques. In this we are using the SCADA microcontroller PIC16 to implement our project. So next is the Java. Using the Java we used to implement the code. So that's, thank you.